And notice it's not running because we don't have the file yet. Okay. Puzzle number 8, Aeolian transmissions. Difficulty rating 1. It's been a day on the ship. You're feeling a little sick, but it's becoming more bearable. Oh, you suddenly remember that you'll have to inform Aeolus' assistants of your upcoming visit to the Aeolian Islands. You reach for your Aeolian, it's hard to say that, transmitter. A special device that enables foreigners to send transmissions to the Aeolian Islands. The device has a special way to store encrypted messages. Encrypted messages consist of uppercase alphabetical characters. I can see that here. The amount of memory units used up by an alphabetical character is equal to its, apostrophe's in the wrong spot, position in the alphabet. For example, the character A takes up 1, B takes up, oh, okay. All right, so we're just adding up the letters. The lab team has already drafted and encrypted the message, but they'll need you to send it using your transmitter. Apparently, it would ruin the mission if they tried to send the message themselves. All right. So we just add up the letters. Okay. Add up, determine the number of memory units required to send the entire message. There's 5 lines in the message. First line takes up this, blah, blah, blah. And we just add up all the lines. Okay. Add up the lines. Println. I think we could just do this. Oh, we first have to get the puzzle input, right? Ooh, nice long lines. Let's go to input. Problem 8. Paste that in. They're all red and squiggly because it's a text file and it's trying to do a spell check on it. So I should turn that off. We're going to go lines. Iter. Map line. Line chars. Map ch. And then it's just going to be the ch as u8 minus b of a plus 1, because a start at 1. And let's just make these all I sizes, because why not? And then we're going to sum that. And then we're going to sum that. Right, so we're just going through each line, adding up all the characters in it. I wonder if I can leave this I size off and it'll understand it. And then it might not be able to, because maybe if I do this as I size, that's a little easier to read than one I size. All right, yeah, so we add up the characters on each line, and then we add all the lines together, and that should give us our answer. We get an answer. Hey, and it is the correct answer. Okay. That's not worth committing. We don't need to commit that. I didn't do a lot of work. After the calculation, you'll send the file size of the message on the Aeolian transmitter to the lab. After a few minutes, you receive a reply. That should be fine, but it would be much safer if you found a way to reduce the message's file size. They seem a little worried. It's probably best if you follow their advice. You check the Aeolian transmitter's notes on compression. There it is. There's a lossy compression scheme that'll reduce the file size significantly. The lossy compression scheme is used on each line individually. The number of characters kept at the start and end of each line is found by dividing the length of the original line by 10, then rounding down if necessary. Then the middle of the line is replaced by the number of alphabetical characters removed from the line. Of course, this compression introduces numerical characters into the message. The number of memory units needed to store each numerical character is equal to the value of the number. For example, 1 takes up 1, 2 takes up 2, 9 takes up 9. 0 takes up so little memory, treated like taking 0 memory. Okay. All right. So first thing we need to do is divide by 10. So we keep the, okay. So it's 21, so we keep 2 on each side. This is 35, so we keep 3 on each side. And then we stick the number of characters removed in between. Okay. All right, we can do that. One thing I would like to do then is change this to be its own own little function. And maybe we could do what we did before. What do we want to call this? Because it's talking about taking up memory units. So let's call it units. And the closure is just going to take a string. Oh, you know what? Let's do it this way. That way I can do this s as ref stir. You know what? I probably could do it that way. Okay, maybe I can't. I don't know. SS, and it's going to return an isize. And it's basically just s as ref, and then this stuff here. But we're going to modify it slightly. What am I? Oh, I have that there. Okay. We're going to say if ch is alphabetic. Oops. Didn't mean to pull up all of them like that. But if it's alphabetic, then we're going to do that. Else, if ch is numeric, then we're going to do almost the same thing, except we're going to subtract this and not add one. Otherwise, it's an invalid character, and we'll just panic. Yeah, invalid char ch. Okay, and this is where I get all confused, right? So let's do this. This goes like that. That looks good. This goes like that. Oh, I have this here. Okay. All right, syntax error. Item or let. What? Oh, no. Yeah, oh yeah, I have this like that. Okay, there we go. Missing trailing quote. Indeed I do. And this should be like this. Still doesn't like it. Oh, I forgot that. Okay. There we go. All right, so now we should be able to just say units here, right? And still get the previous answer, which I've now lost. Let's do this. There. So let's just save that number again, just to make sure. And then I need to call it units of line, like that. There we go. I might be able to just pass in line. I don't know if I can, if it'll take that. It does. Okay. So now what we need to do, now that we have the way to calculate the size, or the units that a line takes, the memory units a line takes up. Let's get rid of that. What we need to do is figure out how to compress it. So let's write a little compression function. Again, as ref stir s, and it's going to return a string. What we do is we get the length of it and divide by 10, s as ref len, divided by 10. And that's how many characters we keep at the beginning and at the end. So we're going to return format bang, the beginning, the count, and the end. So the beginning is going to be s as ref 0.keep. I probably have to reference it. And then the number of characters we're keeping, s as ref len minus keep times 2, right? Because we're keeping on both sides. And then s as ref len minus keep dot dot. Right, and now let's write a test for it. Test compression. So this, we're expecting this value, the string, and the actual is going to be compress of, oops, this value. Right? Let's go over to test, and test passes. Yay! So obviously I did that right. Can we assume that we don't need to test anything else if we got the first one right? Or should we test exactly 10? Yeah, let's do a test for exactly 10. 20, right? And we'll make a 10 one. Come on. Let's do this guy. And this should be A8J, right? All right, good. So now, ooh, unnecessary parentheses. Okay, we can fix that. And then we're not using from stir. Oh, that's true. We don't need, apparently we don't need from stir in this one. There we go. All right, so now we can write part 2, which is going to be lines iter map compress map units sum I size. Run. And we got a different number. Hey, that's the correct answer. All right, so we did a bunch of work. This is worth committing. Git add source, git commit, -m problem 8, parts 1 and 2. All right, git show head. Yeah, so it's basically I did all the code. Okay, very good. Let's continue to part 3. That's a much smaller file size. However, as compression scheme is lossy, some data will be lost after the compression. So you have to make sure the message's content is unaffected. You produce a preview of the message on the Aeolian transmitter. Oh dear, some parts of the message's contents were removed. It appears that lossy compression is unsuitable for this scenario. It's all right though. There's one lossless compression option that the transmitter supports. This lossless compression scheme works by compressing each line separately, replacing consecutive runs of identical characters with frequency value pairs. Okay. So run length encoding. We can do that. Let's do run length encoding. FNRLE. Same signature. Right? And instead of doing this business with a keep as, this looks really bad, doesn't it? Let len is equal to s as ref len. So we'll just change this to len, change this to len, and change that to len. That looks a little bit better. Okay, this is going to be RLE, run length encoding. So how do we want to do this? Let current characters none. It's going to be mutable. Let count is equal to 0. And let result is equal to string from that. Right? And now we say for ch in s chars, if ch is equal to sum cur, no, the other way around. If cur is equal to sum ch, then we're going to add 1 to count and continue. If cur is sum, that means that we have a character, but now it's not equal to the old character. So we're going to say result push stir of format bang of the count, right? Because the count is coming first. I see 2N, 1B, 1U, 5 S's, and so on. So we push the count first, oops, and then we push the character, let sum C is equal to cur, push the character, and then we're going to reset cur is equal to sum CH, count is equal to 1, and we continue. If cur is not equal to sum, it's equal to none, then we're going to set cur is equal to sum CH and count is equal to, oh, that's repeated code. And then at the end, we need to pull in all the remaining ones. So result push stir format bang count, and result push cur unwrap, and then return result. This is assuming this string is not empty. Because this will die if schars is, if the string is empty, then we return nothing. We should do that at the top. If S is empty, we can just do this. If not S is empty, right? Here we go. And then we can clean this up as well. If I do a continue here and change this here, that should clean that up. And of course it fails. Oh, as ref. I forgot. There. I knew I'd get it eventually. And now we actually have to test it. So let's test RLE. We can use this first one again. RLE of this should be equal to this guy here. I forgot the opening quote. All right. Test. Test. Oh, I got to save it. There we go. There we go. Okay. So that worked. That wasn't too bad. I mean, we've done this before. I've done it in Leet Code. I've done it in Advent of Code. It's a common thing. So that's not too bad. Println part 3 is equal to, and we're going to do again, lines, iter, map RLE, map units, sum I size. All right. And hit run, and we get 44020. So it's compressible using RLE, right? The original size was 128 something. Yay, that's the correct answer. All right. Very good. That took, what, about a half hour? I should have time for one more. Let's commit these changes. Okay, good. Git commit -am problem 8 part 3. Okay. Oh yeah, I want to see what the follow-up is. The run length encoding was a great success. The file size of the message has been reduced by a substantial amount. You press the send button on your Aeolian transmitter. Seems like your work is done for the day. Apparently the lab couldn't send the message directly as it would compromise the safety of everyone on the mission. That's a little strange. That is a little strange. Okay. So we go back here.